Okay, so this is about how to analyze your data if you're doing if you're doing an experiment where you have the same thing, you're just increasing the amounts of it. So this would be like if you increase the amount of eggshells, salt, anything like that. This is for you. I have a lot of the data filled out already because this takes a while to do, and I only got like 30 minutes, both in terms of actual time before class starts and also in terms of recording time. So starting here, this is my data table. This is my raw data. Most of you probably have a thing that looks like this, and this is a really good version that for human eyes, right? Where you have condition, 0 of the same thing, 1, 2, 3, 4, 5. X can be whatever you're doing, as well as then trials, 5 to 6 trials per one. The main thing here that I think most people do not have is this uncertainty value, right? Because I have my Medicine units here, which is parts per million of CO2. But as I'm sure you guys have noticed, our tools here are not entirely accurate, be that using a ruler, or if you use some of the probes, for example, I think with the experiment, you saw how much the end value can just wobble. This represents that. What this is saying is that even though my record value is 1769, based on the tool I use, it could either be somewhere between 779 or 1759 with around equal legitimacy. All right, so just make sure you have that. Then certainty there. If you need the plus or minus symbol, it's you go to insert symbol. You can also just do plus slash minus. Okay, in Excel will yell at you. I don't know why, but you can just do that. I think the way to get around it is just put it in quotes. Yeah. Okay. So beyond that, you're also going to want a version of your data that looks kind of like this. This table here takes a little bit of a shortcut because technically each of our data points here has both an X value and a Y value. But what we've done for simplicity of our human brains is since all the X's here are the same, we've just put it up here as a label, right? But for computers and a lot of graphing stuff, it's actually better to have each one kind of spelled out, right? So this is representing, right, we have data point 0, 1769, 0, 1985 as these are our coordinates here. This does not take long to do, but you do want to actually write out this version of your data. Last thing you'll want data table wise is this right here, which is the range count graph. This will relate to our standard deviation and skew as we kind of will graph the distribution of our data. For the range, an easy way to figure that out is do equal min, highlight your data, and it'll tell you the minimum value. And do the same thing with max. I'll use the maximum value. Then from there, break that up into 5 to 10-ish categories. The more, the better usually, but also this takes some time. And then write them here. So this is the range, and this is the count. How to figure out the count, this is a little bit more of a complicated formula, is you'll want the count ifs formula. What this formula does is it takes, you tell Excel, hey, analyze these numbers with this criterion, and I'll return the number here. What this means here is, hey, Excel, look at the cells B through G8, count the number of cells that are above 1100, and yes, you're using the quotes, and below 1301. And this then will count them, right? And saying, hey, with those criteria, there are 11 cells in here that are above 1100, but below 1301. You'll do the same thing, just changing the ranges. The main thing here is that make sure when you put in your values, you make sure the greater than less than sign is facing the right way. And you also need quotes. Do that, and this will tell you the number of cells of each one that you have. If you want to check that you did everything right, you can sum up the numbers here, and it should equal 36. So I have everything here. Right, after you have your condition trials with the data labels, your computer-facing version of your data points, which will be useful for a lot of stuff later, as well as your distribution graph where you have the ranges and counts, you're ready to start analyzing your data. The 4 analyses you need are mean, median, standard deviation, and skew, otherwise known as the average. The median is if you line up all your numbers from minimum to maximum, the middle value of that. Standard deviation is measurement of how spread out each data set is, and then skew represents where the mean and median can compare. I will post a video about that explains a little bit more than I can here. This is also for later where I have the values of each of the conditions just without any of the labels. Because again, as soon as you have any sort of word in your cell or any sort of letter. Excel thinks these are words and will not do math with them. So this is for later. Okay. Luckily, the formula for each of these is pretty self-explanatory. They're generally just equals their name and then the values. The main exception to that is mean. You just need average. They mean the same thing. Then the really cool thing is that if your data is set up correctly, if you click the box here and drag across, the formula will autofill, right? So you just only need to type it in once, and everything else after will be fine. Okay. Moving on, we're going to start with some graphing. Now that we have our mean, median, distribution, skew, the first graph we're going to want to make is a chart that looks like this. I'm going to delete it so we can see everything. So the reason why we typed all this out is so that we can highlight this data, right? Because these are all your coordinates. And then tell Excel you want to make a scatter plot. Right, so scatter plot here basically just graphs each point individually on an XY coordinate. We have all your data graph here. Right, you're gonna want all your stuff on here where you have chart titles, data chart titles, all that. Don't worry about error bars for this one because it would be a little bit too busy. The main thing you do want to add here is a trend line. Right, for trend line, you want to give them more options. Linear is fine. The reason you're going here for more options is you want the equation and the intercept on the chart. The equation is telling you the general trend. Again, this does not mean there is actually a trend there. It's just saying generally the data goes down as X increases. Does not mean it's significant. This is not stats. It's not your p-value. It's just saying here's the equation. The R-squared value is a measurement of how well this line fits all the data points. And doesn't fit the well. An R-squared of 1 would mean that the data fits exactly. So it's not the best fit. This is our first chart, which is just our raw data analyzed, graphing our raw data with the trend line. So that's about all that is. Moving on, what we want to do for our next graph is we want a graph where we do the same thing where we have a trend line, but now we want the mean and the standard deviation. This graph, this is one of the reasons that I made it ahead of time, is a little bit tricky. Because we actually go to chart design and select our data, you'll see I did a lot of kind of weird tricks here. Because the way Excel works is if you want a trend line, the trend line has to be for a data set, which means if we graph each of these points individually, it won't do a trend line. However, Excel also says, hey, if you want to do standard deviation, a error bar, especially a vertical one, you need each of your data points to be individual. So what I did here, and I will actually delete one of my things just to show you guys this. I'm going to delete the 0. Is I graphed all of these just like we did last time, where I highlighted the condition and the mean and just put that on a scatter plot, and did the trend line for that along with the equation. Then to make our error bars work, what I had to do is, I'll show you here, because right now what I had to do is I went to select data and I added an individual data point for each condition. That is the X value and just the mean again. Basically added every data point twice. Once is in its own data set, so we can do the trend line, and once individually, so we can do error bars. Once you have all that graphed up, you want to go to add, error bars, and more options. It'll ask you for which one. We'll start with the 0 condition. Right. And you'll do vertical error bars. You want to go to custom, specify value, positive error is the standard deviation, negative error is the standard deviation. Okay. And I don't know why it's doing horizontal error bars, but we don't need those. And we'll do the same thing with the rest of them. I'll show you guys that one more time, where you go to plus, error bars, more options. We'll do the 1 condition, make sure on vertical error bar, standard error, custom, specify value, positive is our standard deviation. Oh, I did this wrong standard deviation there. Positive is standard deviation, negative is our standard deviation. Click OK. Delete whatever these are. Why is it looking weird? Sorry. Why are you weird? Okay, sorry. Why is you weird? Okay, sorry. Let's try that one. Sorry, I don't know why that was acting up. Let me try that one more time and just see if that's how it is or if I messed up. Okay, both sides, cap, standard, custom error, specify value, negative error is that. Oh, I probably clicked them wrong, but okay. That looks better. Cool. Right, and we'll just repeat that for each of your 5 data points, and you'll have your standard error as well as the trend line. And then the last one you need which is a pretty simple one. If you have this set up, is you need to count distribution graph. This is really, really simple. You just highlight everything, go to insert, recommend charts, bar graph, you're done. Right. The only thing you need is I would insert a trend line. Nope, can't see it over. Go to insert trend line, more options, and I'd probably this one is polynomial. This generally shows the trend of where things are. So this is kind of like a reverse bell curve here. Okay, once you're done with all these, right, this is all your graphs that you'll need. The last thing you need is your R value or correlation coefficient. And this will let you go to your P value. How you get that is you go to your Google Chrome, or you open up your files on accident. You go to Google Chrome and you type R value calculator. Your battery is dying. Okay. Any of these will work. Let's try this one. Nope. Lovely. Okay. Correlation coefficient. Well, yeah. So search that. That looks. Yeah. Okay. This is why you also wanted to put all your things in that kind of like coordinate value, because now what you need to do is you need to put all your x values here and all your y values here. Just remember that even though to you on your graph it looks like, hey, this is just one of these things, each of these is a coordinate with x. For this one, the actual like coordinate for this one is 0, 17, 69. So luckily, since we already did this, we can just copy all of these over here in the x values. Copy all of these. It's under the y values. Then you click calculate R. Okay. Okay, so this will give you your R. Right, you'll want to cite this as a source and take pictures of the results detail calculation, right? All these. Then calculate p-value. I know there's one that has both in the same thing, but this does not appear to be it. Okay. So you'll highlight your R value. Go to here. You'll also cite this one because you use both. 4 is negative 2.0. The n would be number of pairs. I think would be 35, right? Generally, it's n versus no, it'd be 36, right? Because you have 36 data pairs, right? 36 data points. Give me double as that, and click calculate. Okay, so here's our p-value is 0.19317, right? I'll say that this is not so right. Once you have decided both of these, that gives you your p-value. Make sure you take a screenshot of both this and this, right? You're gonna need all of these and as well as some calculation, but this should be enough for your stuff in terms of stats analysis. Let me just see if I can find a better one, because I know some people have been doing it. Let's try this one. Same thing. I think we have our, copy our y's. Throwing you is fine. I'm just trying one that's a little simpler. Again, main thing is since you're using it to copy your data source, you need to cite this as a source because you used it. Calculate. Oh, there you go. Much easier. So yeah, use the Stats Kingdom one because it's a little bit easier, though both have their uses. Right. So here's a calculation. If you want to, you can show the calculation on your thing. All sorts of data things, but the main thing you need here is this one here. At least take a picture of your results and probably also want a picture of your calculations. So this tells you all you need to know, and you can use this. Right. Main thing you just realize is that if your p-value, for your results to not be due to random chance, which these should be due to random chance because I literally just picked random numbers, is that you need a p-value of less than 0.05. But that's the last thing. So I will sign off and start uploading this to YouTube so that it'll be ready for class.